Here's the deal. When it comes to the most exciting satellites of planets in our solar system, most people probably first think about our moon. Well, because it's so close and you can see it almost every night. And then probably come the moon of Jupiter and Saturn, such as Europa and Enceladus with their subsurface oceans, Triton with its methane lakes and dense atmosphere, Io with its immense volcanic activity, and so on. But very often, nobody even remembers Triton, one of the most interesting and exciting moons out there. So what makes it so interesting and why is it so underestimated? Well, let's figure this out. To be honest, it's probably quite obvious why there isn't as much attention to Triton, a moon of Neptune, compared to other famous satellites of giant planets. It's proportional to the sheer amount of information that we get from various missions. And there were a lot of great flagship missions to Jupiter and Saturn. We had gorgeous Cassini, which was probably one of the best of them all. We had Galileo, we have Juno that is still sending back amazing data about the Jupiter system, whereas we as humanity only sent one single spacecraft to Uranus and Neptune in the entire history of space exploration. And what's even more embarrassing, it was just a flyby, which was done by the Voyager 2 mission in 1989. It was back then when we got most of the information about Triton, one of the most unusual satellites out there that we still have today. And the unusual things about it come straight away starting with its orbit, as Triton is retrograde, meaning that it rotates in the opposite direction of the rotation of its planet, Neptune. No other big moons of other planets in the solar system do that. And at the same time, Triton's orbit has very low eccentricity, meaning it's almost a perfect circle, and its plane of rotation matches the planet's equator almost exactly. Triton is also tidally locked to its planet, which is a common thing for big moons. It means that it always faces Neptune with the same side like our moon does to Earth. All that leads to the conclusion that most probably Triton was not formed with Neptune, but rather it was a Kuiper Belt object that was captured by the planet's gravity. There are several hypotheses how it could have happened, as for an object to be captured, it has to lose some of its energy. So theoretically, it could have collided with another object, or Triton could be a part of a binary system like Pluto and Charon. And as it was captured, the second body could be thrown away carrying the extra momentum. Apart from that, Triton is big. Really big. If you look at the size ratio between the Moon and its planet, the only pair that has a bigger one than Triton-Neptune is Moon-Earth. And while Triton is a little bit smaller than our Moon, it actually orbits closer to Neptune than Moon does to Earth. This is why if you looked up from the surface of Neptune, Triton would take up roughly the same size on the sky as Moon did on Earth. Being closer to its planet also means that over time Triton will eventually fall under the Roche limit and will be torn apart by the tidal forces, turning it into a big bright ring around Neptune. However, according to modern calculations, it won't happen for another 3.5 billion years, so it's fine for now and we have enough time to study it. Another weird characteristic of Triton is its albedo. It reflects from 65 to 90% of light it gets from the sun. For a comparison, our Moon only has an albedo of about 12%. This means that Triton keeps itself cold, at least on the surface. Temperatures there are about minus 235 Celsius, which is cold even by the standards of the outer solar system. But despite being out there in the cold outskirts, it appears to be a rather active world. Triton has cryovolcanoes actively erupting on its surface. Instead of hot lava, they spit out ice. This is why there are practically no old craters on the surface of Triton, as it is constantly renewed with the ice from the volcanoes. So, similarly to what we've seen on Pluto from the New Horizons flyby, there are a lot of nitrogen glaciers on Triton. And actually, Triton and Pluto have even more similarities. They have roughly the same chemical composition, their surfaces look very similar, they have similar geological activities going on, they both potentially have a subsurface ocean that is kept liquid by the heat from the core, they both have reddish regions that are a result of sun's ultraviolet radiation, they both have a thin atmosphere, both of them most likely formed in the same region of an early solar system. However, Triton is actually 20% larger than Pluto, meaning that at some point it was actually Triton who was the king of the Kuiper Belt, before it was captured by the cruel planet of Neptune and turned from a dwarf planet into just one of its satellites. And the biggest disappointment is that there are no missions planned to Neptune in the foreseeable future. There was a potential Discovery class mission called Triton, but it wasn't selected. It was supposed to be a flyby launching in 2025 and getting to Neptune system in 2038. But instead of that, we got 2 missions to Venus, Da Vinci Plus and Veritas. And in the latest decadal survey, there is a plan for a mission to Uranus, which is also cool, but the problem is, it's not Neptune. So there is a substantial risk that despite the fact that Triton is supposedly the true king of the Kuiper Belt, we can be left with the 1980s data from Voyager 2 being our best thing for another several decades, which is kind of sad. But it's not over yet. Triton, as well as other mission concepts, still might have a chance. Especially when NASA has finally launched James Webb, which was taking a lot of money from other missions' budget. And rockets like Starship or its competitors that hopefully launch in the near future could be able to give space missions a lot of delta V, which should be a good thing for missions that are flying really far away, like to Neptune. Of course, ideally it would be really cool to have something of the caliber of Cassini or Juno that would provide us with multiple years of scientific data from the giant planet's orbit. Triton is a very interesting place that is definitely worth visiting and studying in detail. It's definitely in the same league with Enceladus, Europa, Titan and other super cool moons, but it's very, very far away, which makes it really hard to reach. But do not let that fact fool you and trick you into thinking that it is somehow not that important. Just remember what we had with Pluto, how it manifested itself and put in the center of a lot of discussions after the New Horizons flyby happened. Previously it was thought that it's a cold, boring world with not much happening, but it turned out to be so much more exciting than we anticipated. So the same could definitely happen when we properly visit Triton. We already know that it's one of the few moons with active geological processes, atmosphere, subsurface oceans and so much more, so we really need a modern spacecraft with modern cameras and other scientific instruments up there. Let's finally explore the true king of the Kuiper Belt that was captured by Neptune. And if a mission will be planned, would you prefer a flyby that would be cheaper and get there much faster, or would you rather wait longer and get an orbiter? Let me know in the comment section. Also, don't forget to give this video a thumbs up if you liked it. We're a small channel, we really need it. Subscribe for more content like that, support us on Patreon, but most importantly, stay curious, my friends.